going to do, and you know how to do these, is determine the derivative. I don't know what number we're on. 6?
Yeah.
Sure.
6?
I'll just write down the first lesson.
Yes.
Something like that.
Okay. 5, please. These ones are going to look familiar because all of these are numerical bases to some sort of variable exponent, which gets taught in chain rule, but I taught it. So, I'm going to give you f of x equals 2 to the x squared plus 3x minus 6. You determine the derivative of that. We have to spot these ones every single time because they're a numerical base to a variable exponent, and they do chain rule, but they have their own little chain. Okay? So remember what we do? We rewrite it in one chain. Ln the base, so ln of 2. And then in the last chain is the derivative of the exponent. So 2x plus 3. That's it. This one, we could do dy over dx. Remember, that means derivative, just in a different way. So we rewrite it. Ln the base. Derivative of negative x is negative 1. And often they'll bring the negative 1 to the front. But you can leave it at the back, it doesn't matter, right? Because it's multiplication. And then c, we do g prime of x, rewrite it. Ln the base. Derivative of the exponent. So the derivative of this one is another one of these. So we rewrite it. Ln the base. And then derivative of the exponent. That becomes a 1. They'll often bring the 2x minus 4 to the front, which I switched. And they might rewrite it as a 2x minus 2. That's not right. Once again, you could leave them in any order because they're multiplication, right? Okay. Example 7. Determine the tangent slope of the following. Oh my goodness, guys. Put a piece of paper over that part of the board.
It means the snow just
To stop soon.
It means it's like snowing now. That snow's to stop.
I feel like that's not a good sign.
Yeah, it isn't.
Okay, let's not board. I know you don't like me as it is, so you're kind of bad. We're not going to make it any angrier. This board sucks to be. I mean, you're bored. You're great. Love you. All right. So we're going to do f of x equals 3 minus x cubed to the negative 5. So we have to spot these when we have the one chain rule was the weird one where it's like numerical base to variable exponent. But these ones you have to spot because remember they have like an f outside and then a g composed inside. So in this case the f would be x to the negative 5 and the g would be 3 minus x cubed, right? So whenever we have that outside and then inside composition, we have to do chain rule. Now sometimes you could have a chain rule within a chain rule, right? But you would just work your way from outside to in, kind of like we did when we would convert logs to exponentials. If we had like 3 logs, you convert to an exponential, convert to an exponential, convert to an exponential. So it's always outside in. So this one, we get f prime of x. What do we get first? Negative 5, I heard someone whisper answer that. Yeah. Then we rewrite the inside. We do not change the inside, correct? We always do the derivative of the outside, rewrite the inside. That is a 3, I don't know what you're talking about. And then to the negative. Yeah, don't judge it. It's just as good as a 3 as that 3. And then to the negative what?
6.
6. And then I'm done.
No.
No, what do I have to do?
I want to do the derivative of the
Derivative of the inside. What's the derivative of 3 minus x cubed?
negative 3x squared.
Now, sometimes they will write it with a positive exponent instead, so they'll take that whole thing to the negative 6, drop it to the denominator, make it to a positive 6. So, and then they'll make the top join. So they'll get 15 x squared all over 3 minus x cubed to the positive 6. B. F of x equals, you're going to try these two out. E to the x, and then times x squared plus 1 cubed. So, you have to decide every single time you see it, what am I actually doing and what do I have to do to get that derivative. So, for example, the one above, I actually have to do chain rule in order to solve it, correct? This one is actually a what? A product rule. Why is it in the chain rule lesson? To get g prime, you have to do a chain rule. That's why. So really, this is a product rule question with a chain rule having to happen to get g prime, right? And how do I make myself realize it's a product rule? I will always go in there and put like a big old dot and be like, dude, there's two things multiplied. Product rule. So you're going to try that one out. And then you're going to do C as well, which is g of x equals 3x plus 2 over 4x squared minus 5 to the 5. Now, what is this one? Actually, you have to do what first? You have to do the chain rule first, because you do the derivative of the outside, and then follow behind the chain of the derivative of the inside, which is quotient rule. So you have to do chain rule first, right? You have to drop that 5 in front, rewrite it to the 4, and then quotient rule behind it in chains. Yeah. So try these two out. This one here, we have product rule first. So this is our f. This is our g. Our f prime is e to the x. That's a great thing about e to the x. Our g prime, we have to use chain rule, which is why it's in this lesson. 3x squared plus 1 to the 2 times 2x. So it'll get rewritten as 6x x squared plus 1 squared. So that is without doing the derivative at all, right? We're just getting f and we're just getting g. Then we have to actually do product rule. F prime of x is g times f prime plus f times g prime. Now, I told you whenever you have an e, right? Whenever you have an e to the x, you'll always be able to take out an e to the x because it has a chain rule, because we're doing chain rule, and that's why we can take it out. Whenever your f or your g is also a chain rule, you'll be able to take something out. So if you look here, g is a chain rule, isn't it? G prime here is a chain rule. So we're also going to be able to take something else out. So you have to watch yourself when either your F or your G is a chain rule, which actually both of our F and G's are chain rules. We'll be able to take something out for both. So we look at this one, we look at this one, and I say, okay, I can take an e to the x out. What else can I actually take out? An x squared plus 1 to the 2. Now the great thing about chain rules is when you take out one of the chain rules, the other one's just going to turn to a 1 because it's always one less because you're taking 1 off of it every single time because you're doing power rules. So the 1 will go away and the other one you'll be left with it to an exponent of 1, which is great. So I'm going to get an x squared plus 1 to the 2, and then I write what's left over. So the e to the x is out. X squared plus 1 to the 3, if I take out 2 x squared plus 1s, what am I left with? Just 1. X squared plus 1 to the 1. Do I have to write it to the 1? No. So it would just be x squared plus 1 plus, I can keep it in brackets, speed line. This when I take my e to the x out, it's gone. I take an x squared plus 1 to the 2 out, it's gone. So all I'm left with is 6x. And sure, I can leave them in brackets, but do I need to leave them in brackets when it's a plus sign in between them? No. So I would actually end up with e to the x squared plus 1 squared, and then x squared plus 6x plus 1, which can't be factored. So I am done. We're literally spending the rest of the class. Here's 2, do them. Here's 2, do them. So when I release people onto it in the homework, people will do all the homework and they up in the back like, it doesn't match. It doesn't match. It's constant. If we do enough, then you feel confident in knowing what to do. Okay? Chain rule is literally, chain rule, product, and quotient together is literally just, have you practiced enough? If you practice enough, you find them really easy. If you haven't practiced enough, you just fall to oopsies. Okay? So for this one, the first thing we have to do is the chain rule, because it's all to an exponent. So we're going to get 5 to the 3x plus, no, 5 with the 3x plus 2 over 4x squared minus 5, all to the 4. We agree? Then behind that, we have to do quotient rule, right? I'm not joking. People either like love derivatives by the end because they can just do them and they practice them enough, or people hate them because they're like, I don't freaking know what to do next. I'm just going to do the derivative of that one over the other one and call it a day, and then it's wrong. So I kind of don't allow you to not do enough. I kind of force you to do them in class. It's a great thing. So forcing work. Profs don't do that, so enjoy being forced to do things. Because next year you won't be. You should want to be. Okay. So we're going to do G, which is 4x squared minus 5 times f prime. Remember, the top is always f, the bottom is always g, right? Product rule can be f, g switched. It doesn't matter because it's multiplication. But quotient rule has to be f, then g. Okay, we get g, and then the derivative of f prime is just a 3. Minus f, which is 3x plus 2, times the derivative of g prime, which is 8x. All over g squared. Now, even if you did this, I bet you aren't going to have the answer that I'm going to have in the end, because when I show it to you, you're like, oh, I can see I can keep doing it. Keep going. So this one happens when you have a quotient rule locked inside some sort of chain rule. Okay? So we'll finish up the top part. We're going to get the 5 in front. I don't know why I wrote it so small the first time. Then I can put the 4 to both of these separately, actually. So instead of writing it as a big bracket, and I'll show you why I do that, because they're going to have a whole fraction. I was going to do it in the next step, but I'll do it this one. So we can get 3x plus 2 to the 4 over 4x squared minus 5 to the 4. What's this 5 over?
1.
It's over 1. I'm going to put the 1 so people don't try to put 5 to both the top and the bottom, which I see happen all the time. Now, if you put a 5, people are like, does it go to the top, does it go to the bottom, or does it go to both? Think, if I put it to the top and the bottom, I'm putting is 5 over 5. 5 divided by 5 is 1, not 5. Yes, that's what you were saying. You're proving that. That's what, yeah, exactly. Totally, I agree with you. Okay, so we're going to distribute here, and we're going to get 12x squared minus 15, and then minus 24x squared minus 16x. All over 4x squared minus 5 squared. I'm not sure why I'm putting brackets around both of them. Like, they don't need the brackets. So I can get 5 over 1. Sure, you can do it like that. And then I can get 3x squared. That's not squared. Three x plus 2 oh, I did. To the 4 over 4x squared minus 5 to the 4. And then here I have on the top negative 12x squared minus 16x. Right, computer's going slow. Minus
16. Wait.
Nope, I mean minus.
Plus
Over. But you're going to have to put the minus in. 4x squared minus 5. So most people will leave it like this without distributing the 4 to both the top and the bottom. Do you see that? Like they might just write it as this to the 4 and then that sitting behind it. The reason why you distribute the 4 into both of them is because I can actually put these together. 4x squared minus 5 to the 4 times 4x squared minus 5 to the 2 is 4x squared minus 5 to the 6. So they'll always put them together, and you'll sit there and be like, how did they get one denominator? Well, they got one denominator because they didn't just leave it like this fraction to the 4. They'll split them both up to the 4, and then they put them together. And they can put them together because both of them are g's, right? I have a g squared, and the other one is just a g on the bottom. So, of course, they're going to be able to get put together. So on the top, I'm going to get 5, 3x plus 2 to the 4, minus 12x squared, minus 16x, minus 15, all over 4x squared minus 5 to the 6. Now some people will say, what happens if I can't do derivatives? You're in big trouble. And then some people will say, well, what happens if I can't get it to look like that? You're in big trouble. Because next unit, we have to get it into these separate terms like this, because that will give us our critical numbers to teach us how to draw graphs without our calculators. It gets us our max and our mins, because someone ruined it for us and taught us that if there's a horizontal tangent, that's where the maxes and the mins happen. Someone did it? So that's the whole, basically, learning curve of the next unit. So if we can't get them into these, we can't get critical numbers. So, oh my gosh, guys, I'm going to put paper over the bar. I'm not on the board. Okay.
Why does it say so many different things?
To
the
ruin
line
your
is
life.
constantly changing.
Yeah. C. What if I give you string?
See. Split 2 apart.
I adapted it to
Well,
y equals 5 cos squared 3x plus 2. So I have to explain something to you guys so that you don't realize that you understand this is a chain rule. So when you do trig, remember I told you if the squared was in the middle, you literally can't type it in your calculator that way. Like if there's a squared in the middle, you can't go cos squared, because the moment you press cos, a bracket opens up. You literally can't put a 2 in there. Some people are like, oh, put 2 after the bracket. No, it has to be between the cos and the bracket, right? There has to be a squared. You physically can't do that on your calculator. You press cos, a bracket opens up. People are like, challenge accepted. Can't happen. So challenge away. But how do we put it into our calculator? Because the moment it goes cos and it opens up. Yeah.
You put it all in brackets and then square it.
All in brackets and then square it. So you'd go cos 3x plus 2, right? But you have brackets around the entire thing squared. It just means there's 2 of them, right? If I had x plus 2 squared, that would mean I have an x plus 2 and an x plus 2. Do you agree? So could I, if it was squared, could I technically draw them out and do product rule? Yeah. Would you do that? No. We're going to do chain rule. Because what we're going to do when we see this, the very first thing we're going to do when we see this is rewrite it with the squared out, and then it's just a chain rule. So if we forget that step, this becomes an aggressively hard question. So we're going to go 5, and then we go cos 3x plus 2 squared. And now you see it as a chain. Because what can we do? Take the 2, drop it in front, right? Raise to the power of 1. Then do the derivative of what's inside. So do you see how product rule, quotient rule, derivatives of trig functions, derivative of exponents now comes into account because we could have them embedded in a chain. So honestly, you've learned most of the derivative rules now, so we just practice for a couple days so that we can just do them really, really easily. Okay? University, you don't get that. You're done and you move on to the next lesson, right? So we get the extra time to do that. So when you drop the, people are like, okay, now I do the derivative of the inside. I'm like, no, you haven't done anything. And this shouldn't be a prime. Lepp, idiot. So dumb sometimes. That is just why. But you guys will put primes all the time. And I was just going to mock you and say that, and then I found out I did it, which is kind of comical. So you'll write prime because you're like, oh, that's first derivative. No, you didn't. You just rewrote it in a different way so that you can find the derivative, right? So there shouldn't be a prime there, even though I put a prime. Cool. So we have y prime now. The 2 drops in front. 2 times 5 is 10. Rewrite the inside. Oh, my computer is going so slow. I have to write so slow. And it's technically to the 1. Do I have to write the exponent 1? No, but I'm going to. Then I have to do the derivative of the inside. What's the derivative of cos? Well, it starts with a c, so we know at the very least it's negative. Negative sine. Cos and sines are the easiest ones. So it's negative sine. Rewrite the inside. Now keep in mind, whenever you have a trig that doesn't just have an x inside it, it's a chain rule. Because we're going to do the derivative of the outside, make it sine, and now what do I still have to do? The derivative of the inside, so I get a 3. Now you could leave it like this. You will never see this. They'll take the negative 1 in front. It's not attached to the sign. People think it's attached. It's multiplied. So I could just go negative 1 in brackets. I could do this if I really wanted to. Just got rid of the negative 1. And I can go 3 times negative 1 times 10. They'll take all the coefficients. They'll bring them to the front every single time. You look like you're hurting.
I have no idea if we get out of it.
Yeah. We'll watch. Maybe laugh. Negative 30. And then cos, not sure I'm putting this in a bracket because I don't have to. Why don't I have to put this in a bracket? The outside of it. Because it's to a 1. Now, if it was to the power of 4, I still wouldn't put a bracket around it. I would put the 4 back in the middle. So in your very last step, if you have it to like anything other than a 1, you bring that number and you put it back in the middle. Like you rewrite it back where it was every single time. And then we have sine 3x plus 2. I'll put in brackets as well. E. You guys try this one. Y equals sine cubed I over 2x. Try that one out. The first thing we're going to do is rewrite it all to the 3 without a prime. I pressed purple, but whatever. So we'll stay with blue. So sine pi over 2x all to the 3. If you miss that step, I don't know what you're doing. Just put tape on your paper. I don't know what's going to happen. Okay. So if you miss the step where you put the 3 outside, you're not going to get this right. Correct? So that's the essential step you got to spot right away so that you know to do chain rule. So we get y prime equals 3 sine pi over 2x to the 2. Then I did the outside. Now I have to do the inside. What's the derivative of sine? Not negative.
Cos.
It's cos. And then pi over 2x. And I'm done. No, what do I have to do? Take the derivative of pi over 2x, which is? It's just pi over 2. Okay? Now, they will probably move the pi over 2 with the 3 at the front and write it as 3 pi over 2, because 3 times pi over 2 is 3 pi over 2. They will take this 2 and they'll put it back in between. So you take it out to do the chain rule, but in your very last step, you'll take that exponent that's outside and you bring it back in, right between the sign and the number, right? So we're going to get 3 times pi over 2 is 3 pi over 2. And then we're going to get sine squared pi over 2x. They will always bring it back in. Cos pi over 2x. Thanks, man. He just did. I can't even do it. Okay.
Why is there no squared on the cos?
Because it's not squared. Because you're just doing the derivative of the inside.
So we don't include the square?
No, that's chain rule. 3 dropped in front, drop to a 2, do the derivative of the inside, and do the derivative of the inside. So there's no squared on that. The sign, pi, yeah.
Why are they dropping in? The 2 back in.
Because if they don't drop it in, it could be on the actual pi over 2.
Oh.
So if it's outside, it would be here, and then it'd be the pi over 2x squared. So to get rid of is it the whole thing squared, or is it the squared? So if it's the whole thing squared, they'd have to write the whole thing in brackets squared every single time. So instead of doing that, they just put the 2 in the middle. Because they have to put in brackets, or else it's applied to the pi over 2x. Okay, I'm going to have you guys do this. You're going to go to page 227.
I can open it. I don't really want to walk all the way to.
Yeah. Can you imagine how heavy this book would be if they weren't this skinny? It'd be crazy.
Probably enough to cause a space-time distortion. Probably.
Possible.
With having so many rapid
I still haven't done that.
But yeah, it would be noticeable.